Welcome to One Concept Per Day portal. This is question number 2. So we are currently working on Coulomb's law. Okay. So this question is taken from November 2006 paper, and this is in paper 3 in data analysis. Anyway, the question is very similar to whatever concept we are dealing. So therefore, I have taken this question also to show what are the variety of questions that you get in your paper. Instead of looking just the past papers of the old 2016 to 2024. Okay, so you can also look at these questions. Some of these questions are really good, excellent questions, okay, which will help you initiate the critical thinking, and you will be able to do well in your exams. That's why we are doing this one. Okay. Now the diagram shows some apparatus similar to that use the Coulomb to establish the relationship between the force between the point charges and the separation. This is a fixed support. This is a quartz fiber. Small metallic charge sphere is being present over here. This is an insulating rod. There is a scale. A circular scale is being present. With the aid of the diagram above, outline how the apparatus may be used to determine the relationship between the force between the charges and the separation of the charges. So he is asking you to do a design of the experiment. So how do you do it? So what you do is, simple thing is that you need to repel it and you need to find out, right? So it's only one sphere. You need one more sphere. Take one more sphere, keep it here. Okay. You measure the distance between them. Measure the distance between them. R is the distance. So as a result of it, what happens to the sphere? Since it has been tied over here, this gets repelled and it might move to this one over here, this point over here. Now what you do is measure the angle between, okay, the displacement from here to here. From here to here. This will be your angle theta over here. This position you should already mark it. Okay. The moment you got this one here, it got deflected like this, right? So therefore, now what can you say? You can say if the distance is so much, then this is what happens over here. Thus, the force of repulsion will be proportional to theta. Can we say that larger the force of repulsion, larger is the force of movement over here. Okay, and smaller the force of repulsion, smaller is it. So correspondingly, what will happen? This is a pointer here, right? How do you measure the deflection over here? See, earlier it was like this. Now what will happen is this will now be pointing like this over here. This will point like this. So actually, you are not measuring it here; you are measuring it here in the circular scale. This is now moved by 5 divisions, 6 divisions, and so on. You are measuring this one here. Okay. If you bring a larger value of the force over here, charge over here, then definitely this will now get deflected like this, and the deflection would be seen here. If you are moved like this, and the deflection would have seen here, right? From here to here, I am going to measure over. So this could be theta 1, this could be theta 2, and thus you can say F is proportional to theta. Larger the force, larger the angle. That's one thing. Then what else can you do? Outline how the apparatus may be used to determine the relationship between force between the charges and separation of charges. Now what we have shown is that larger the charge over here, just kept at a given distance, this sphere, larger the force. Okay. So F we know is directly proportional to Q, So if larger the Q, then theta is also larger over here. This is what we have seen. The next thing is that he is also asking you the distance between the charges, separation of charges. So what I can do? I can take this one sphere, I can keep at this distance R1 and find what is the deflection. Now what I can do next time, I charge it with the same charge, keep it over here. Okay, when I keep it over here, then what happens? The distance is much larger here. See, this is my distance here, R2. In that case, do you think this will move further? No, this will not move until here. It might move only until here, right? Which means what? Larger the distance, lesser the force. Okay, so you are able to prove both of them. Now, what is that I need to write here? With the aid of the diagram, outline how the apparatus may be used. So, the 4 marks you need to write. Bring one more charged sphere and keep it at a distance r from the first sphere. First thing. Secondly, notice the angle. Measure the angle. Measure the angle of deviation. This implies force which is proportional to charge, which is proportional to theta. So this is one thing which we measure. Next, what we do? Move the charge a bit further away from the first sphere. Maybe I should write move the charged sphere a bit farther away from the first sphere. Note the deflection now. So now what is the observation? Observation is that we find that as R increases, theta reduces. R force reduces. Okay, do not mention that F is proportional to 1 by R square. Nothing has been told to you so far. Do not mention, just stop until here. Okay. Now, by knowing the ratio of the two charges on the two spheres, Coulomb also established the relationship between force and the magnitude of charges. Explain how Coulomb determines ratio. Simple question. So, what you do is, you put one charge. Okay, let us say I take one sphere here. I'll take one sphere S1, which has a charge Q1. Okay, and then I put it over here at a given distance. Let us say distance is 10 centimeter. Okay, S1 with a charge Q1 and a distance of 10 centimeter. I found out what is the deflection. Okay, deflection is theta 1. Next, what do we do? Now, what is he asking? Okay, so now what is the force acting between them? The force acting between them, as we know by Coulomb's law, is nothing but K Q1 Q2 divided by R square. Next, what I do? I take one more sphere. Okay, this was a sphere S1. I take another sphere S2 and charge it with the charge Q2 over here, and then keep it at the same distance 10 centimeter. Then what will be a deflection? Do you think deflection will be theta 1? It won't be theta 1, right? Because it's a higher value of Q2. Let me assume the charge is much higher or much lower, whatever it is. Okay, let me assume it's higher. Then this will now become theta 2, and then the force here would be K Q1 Q3 divided by R square, right? So therefore, I have different forces over here, different angles of deflection. Now, how do I assume, how do I understand that charging this with a different charge has made the sphere to move away? So what I do is, he says very clearly, okay, let me first write down the equation so that I can read the question and again go back. With the first charge Q1, I had F1 is equal to K Q1, sorry, first charge Q2, because I call this Q1 as the initial charge present in the first sphere. Q1 Q2 divided by R square. I'll write this as F2 for clarity. With another charge Q3, I'll write F3 is equal to K Q1 Q3 divided by R square. Value of R is not changing, only F2 and F3 are changing because of Q2 and Q3. By knowing the ratio of the charges on the two spheres, okay, now what I do is, I find out the ratio. How do I find the ratio? I know that Q2 by Q3 is known to me. Q2 by Q3 is already known. Okay, it's already known to me. So if it is known to me, then establish how Coulomb determines this ratio. Explain. Coulomb also established the relation between force and magnitude charges. Explain how Coulomb determines these ratios. So what we do is, you just find out the ratio of these two. F2 divided by F3 will now be equal to Q2 divided by Q3, right? When you see that there is a proportionality over here, as F increases, Q also increases. Let me assume I do not know anything about it. Okay, I get Q2 by Q3. I also know what is F2 by F3. And then what I do is, I just divide one by the other, and I find out that as this ratio increases, okay, this ratio also increases. So that's what can we say? We can say that as the charge increases on the second sphere, the mutual force of repulsion between them also increases. Thus we can say this force should be proportional to Q, right? So we can write like this also. So this Coulomb was able to establish or determine, okay, making use of this ratio, okay, how does the power force between any two charges changes, and thus we say the force is proportional to charge. So with this, we come to an end to this question, and let us see tomorrow's concept in the next video. Thank you.